Hi, this is an AP Chemistry video. We're going to be covering topic 4.9, redox reactions. So a redox reaction always involves losing electrons, which is oxidation, and gaining electrons, which is reduction. Sometimes we say Leo goes GER to help us with that. So Leo is loss of electrons, is oxidation, and then GER is gain electrons, is reduction. So every redox is going to have, the oxidation and the reduction occurring simultaneously. So the reaction itself can be constructed from half reactions. So a half reaction, one will show the oxidation, one will show the reduction. So these are kind of the steps for when you're writing out half reactions. And so we can do this problem together right now. So let me grab a page. So if I have this reaction right here, and I'm trying to write out the half reactions, I'm going to follow these steps. So the first thing I'm going to do is assign oxidation numbers. So 0, +2, +3, and 0. Then I'm going to decide what is oxidized and what is reduced. So I can see that the aluminum metal is oxidized and the copper ions are reduced. So then I want to write out those half reactions. So my oxidation is going to be the aluminum solid turning into aluminum ions. And then that would be a loss of 3 electrons. The reduction is the copper +2 ions would have to gain 2 electrons to become neutral copper metal. So then these are the half reactions. If I want to write the net ionic equation, I am going to make my electrons equal. Electrons are conserved, so as many as are lost have to be gained. So you can see that we would have to multiply this reaction by 2 so that we have 6 electrons being lost, and this one multiplied by 3 so that we have 6 electrons being gained. So I'm going to rewrite that out, and then we're going to sum up the reactions. So when I add, I can cancel those electrons, and then everything else is going to be part of my net ionic equation. Oops, I forgot my 3, didn't I? I do that sometimes. I forget when I'm distributing. So yeah, so that is, let's keep going. I'm going to just keep covering content with you. So the half reactions, like we just did, can be used to write the net ionic equation for the balanced redox. And then, like I was saying, the electrons that are lost by one species must be equal to how many are gained. So let's do a couple examples. So now we're being given the half reactions, and we're going to write the balanced net ionic equation. So first thing, they want to know what is oxidized and what's reduced. Oxidized is when it becomes more positive. So the chromium solid is oxidized and the silver ions are reduced. And then write the balanced net ionic. I'm going to give myself another page. So what we're going to do here is I'm going to rewrite, actually, I'll bring these down. So if I want to write the net ionic, I do need to make sure my electrons are conserved. So I'm going to multiply this bottom reaction by 3. So when I do that and then sum them together, I'm going to have chromium solid plus 3 silver ions that are in solution plus 3 electrons is going to form chromium ions plus 3 silver neutral atoms plus 3 electrons. I didn't leave myself enough room. And again, just realizing that those would cancel out. So you could just not include them, so sometimes I bring them down and show that, and sometimes I don't. So the net ionic redox reaction is circled. So we've got some similar problems to that. So I would recommend trying these before and then, pausing the video. But I will work them out and show you my thinking process. So up here we have the reactions. So what is oxidized is going to be the cobalt metal, and what is reduced is the silver ion. So when I try to write the net ionic equation, my cobalt is going to turn into cobalt ions, my oxidation here, half reaction. And then my reduction, I am going to want to multiply that by 2. So I would have 2 silvers ions plus 2 electrons, and then I get 2 silver neutral atoms. So now when I sum these to write the net, I'm going to this time just cancel those electrons right away. So I would have 2 silver plus 1 ions plus cobalt makes cobalt ions plus 2 silver metal atoms. All right, let's do another. This one here. So this one, we are going to, what are we doing with this one? Let's do it. Let's assign oxidation numbers for this first. So aluminum is 0 there. The nickel is plus 2. Oxygen's always minus 2. So I think the nitrogen is plus 2 there. I might have to double check that. Let's do that together. So we know this is plus 2. So 2 plus 2 nitrogens plus 3 oxygens. And overall, this is going to add up to 0. So 2n minus 6, so minus 4 is 0. So n would be plus 2. So I was right. But that is kind of from a previous lesson, just determining oxidation numbers. The aluminum is plus 3, nickel is 0. If we work it again, we don't need to. The nitrogen's going to be plus 2 when it's in the nitrate ion. So we can see that the aluminum is oxidized and that the nickel ions are reduced. So let's write out those half reactions. And we are going to not include the nitrate because that is just spectating. So write the oxidation half reaction. That would be the aluminum becoming aluminum plus 3, and then 3 electrons. And then the nickel is the reduction, half reaction is the nickel plus 2 electrons will make it into nickel solid. So we, again, would have to make sure our electrons are conserved. So you can see that I'm going to need to multiply the top reaction by 2 and the bottom reaction by 3 so that I have 6 electrons total being gained and lost. So I am going to distribute and add together at the same time. Plus 6 electrons. It's going to give me 2 aluminum ions, 3 nickels, plus 6 electrons. So we can cross out those electrons or erase them, never include them from the beginning, whatever you prefer. So I'm just going to erase mine, and then that left over is my net ionic equation. So I did take out the nitrates because they are just spectating. All right, so now we're going to do some more complex balancing of redox reactions in acidic solutions. These are the steps that we're going to follow. By the way, you can balance in basic solutions too. It's not that hard. I'm not going to cover that though. And I'm only going to do this type. So when we do balancing a redox in an acidic solution, the first thing you want to do is assign oxidation numbers. So if I work these out, the chromium is +6, oxygen -2, the chloride ion is -1, chromium ion is +3, and chlorine diatomic is 0. So I'm going to then write the half reactions of the reduction and the oxidation. So I can see that chromium is reduced. It's becoming more negative, less positive. And I can see that the chloride ion is oxidized. So it is going to, is that right? It makes my brain hurt a little. I think that's right. Yeah. So here we go. So the dichromate ion is going to be reduced. So we're going to gain electrons and form chromium +3 ions. And the chloride ion is going to form chlorine, and it's going to lose electrons. Again, I'm not putting the amount of electrons in there yet. So next step, I'm going to bring this down so I have more room, is we're going to balance all of the elements except for oxygen. So what I mean by that is like I want to have 2 chromiums on both sides and 2 chlorines on both sides. So now we're going to deal with the oxygen. So you can see this reaction has oxygen and then there's no oxygen on the product side. What we do is then we add the water back in. So I would need 7 water molecules. So this redox reaction is happening in water and in an acidic solution. And we do one of these in class. So we add water. We're also, everything is aqueous, so it's in water. And then we also added sulfuric acid. So the reason we add the acid is if you look here now, there's hydrogen ions on the product side. We would need to have 14 hydrogen ions on the reactant side. So now all of the elements are balanced. So the next thing we're going to do is balance the charge with the electrons. So the side that doesn't have any electrons, I always calculate its charge first. So this right side is going to be overall +6. So therefore, we want this side, the reactant side, also to be +6. So notice that we have 14 positives plus -2. So overall, right now, it's +12. You want it to be +6 So we would need to have 6 negative electrons, and then it would be plus 6. And then let's do the chlorine. So this side is -2. Right now, this side is 0. So we would need to have 2 electrons. Now we are going to make sure our electrons are equal on both sides. So I would have to multiply this reaction by 3. So when I do that, oops, I'm trying to add a page for more work, and there we go. Okay, so when I do that, I'm going to sum these together and also be distributing this 3 through. So I'm bringing everything down. I would have 14 hydrogens, 6 chloride ions. I would have the dichromate ion and 6 electrons. And then on the product side, I have 2 chromium ions, 7 waters, and 3 chlorine. So if you want to put states of matter in, all of the ions are going to be in solution. Water is a liquid, and then chlorine is a gas. So yeah, so we're almost done. The last thing, again, we would cancel out the electrons. So some of you might prefer to just don't bring them down from the beginning. Oops, and I didn't. See, I already, let me show you. I forgot to bring the 6 electrons to this side. So now you can either, draw a line through them or, get rid of them. So let's do one more of these. So these are balancing redox reactions in acidic solutions. I would definitely try this and pause the video and see how you do. Assigning oxidation numbers, the sulfur here is +5. Oxygen is always -2 unless it's in a peroxide. Bismuth is +5. Oxygen -2. Bismuth here is +3. This sulfur is +6. Oxygen -2. So you can see that the sulfur is oxidized. It's getting more positive, and the bismuth is reduced. So I'm going to come down and write my ox, which is the ion with the sulfur. I can't remember the name of this one. Oxidized, yeah. So I'm doubting myself. So we know that there's going to be electrons, but we're not going to try to put those electrons in yet. And then the bismuth is being reduced. So there's electrons being gained, and then it becomes bismuth 3+. So this one is fun because you get to add water and hydrogen to both sides. So I can see, and well, don't forget, this is one of my most common mistakes is to forget to balance the element first. So we would want to definitely balance that sulfur. And then we want to look at water and for the oxygens. You can see I have 8 oxygens on the right side and I have 6 on the left. So that means that I am going to get rid of that so I have more room. That's my ox. I'm going to add 2 water molecules. So now I have 8 oxygens on both sides. Now I have hydrogen ions. You can see I have 4. So I would need to have 4 hydrogen ions over here. We'll go back and do the electrons in a second. So now the other one, we have the oxygen. So we would need 3 waters on the product side. And then you can see that we would have 6 hydrogens. So we would want to put 6 hydrogens over here. So now let's determine the electrons. So this side over here is -2. This side is -4 plus 4 here, which is 0 at this point, but we would then need to have 2 electrons. So the charge of the sulfate is -4 and the charge of the hydrogen is +4. So before I add the electrons, it's 0 on the right side, but we would want to have it be -2, so we would add 2 negative electrons. Next one, you can see this side is +3 and this side is +6 right now. So we would have to add +3. Oh wait, sorry, it's not +6, it's +5. So we would have to add 2 negative electrons. So the good thing is we don't need to multiply the reactions to get the electrons to be equal. They already are. So now when I sum, I'm going to bring everything down just to prove it to you. So on the reactant side, I have 2 waters. I have S2O6, 6 hydrogens, and that ion with the bismuth. And I have 2 electrons. On the right side, I have 2 sulfates, 4 hydrogens, ions, bismuth ion, 3 waters, and 2 electrons. So I'm going to start simplifying, getting rid of my electrons. And you can see the water, I am going to subtract 2 waters from both sides. So this is going to be no water, and over here we're going to have 1 mole of water. And then similarly, we'll do the hydrogen ions. I have 4, so I'm going to subtract 4 from both sides. So I have 0 hydrogen ions now, and over here I have 2. So then I would rewrite it, and you can do all that in your head if you want. I just wanted to show you. So in the end, we have this sulfur-containing ion and 2 hydrogen ions, the bismuth ion, and then let's make sure I'm not forgetting anything. And then on the other side, we have the 2 sulfates, the bismuth +3 ion, and the 1 mole of water. And again, states of matter. All right, and that's all I have. So if you have any questions, don't hesitate to ask.